everyone, welcome to Legacy IAS. Now, we will be continuing our time and work series. Now, in that, we had seen in the first video, some basic introduction about time and work. Then we saw some simple or basic questions related to it. Then we did some combination based question. Okay, that A and B together, A, B and C together do this work, this, that. Now we'll be doing questions in which someone leaves or joins midway. So in the midway, someone will leave or join. Okay, those questions are A and B started working together. Then after working for 8 days, A left. The remaining work was completed by B. Like this questions. So that we'll see. Let's get started. Okay, so this is the question. Now, A can do a piece of work. A and B can do a piece of work in 4 days. Oh, sorry. What changed? Yeah, this one. Yeah. A can do a piece of work in 12 days and B can do it in 18 days. They work together for 2 days, then A leaves. How long will B take to finish the remaining work? See, how you solve questions like this is by drawing a very basic timeline. Like this. Now see, here at the top you write the time. Below the line you write the efficiency. Okay, these are the two terms you have to write. Now just divide it like this, and now you know one thing by the basic lectures, that work is equals to efficiency into time or time into efficiency. So if I multiply this term and this term, I'll get the work here. Now let's get started. So first thing what we have learned in basic lecture, 12 days, A completes something in 12 days, B completes in 18 days. So how you used to find total units of work? Total units of work was LCM of both of these, that is 12 and 18. What is the LCM? LCM is 36, 18 to the 36, correct? So 36 is the LCM. That means total units of work is 36 units. This is the total work. Now, they work together for 2 days. So, for how many days? 2 days. Who is working together? A and B. So, let's write A plus B. Now, here what we write? The sum of their efficiencies. Now, see, if 36 units is total work, 12 is the time that A takes, then A has an efficiency of 36 by 12, that is 3. Similarly, B has an efficiency of 36 by 18, that is 2. Now, A plus B will be what? 2 plus 3, that is 5. Now we go to next. Now so they work together for 2 days, then A leaves. How long will B take to finish the remaining work? So A has left. Now let's say X days are taken here. Okay. And who is working for these X days? Only B. So only B is working. What is the efficiency of B? B's efficiency is 2. Correct? Now you simply multiply them to get units of work. So work done in these 2 days is 2 into 5 plus. Work done in these X days is X into 2. Correct? Time into efficiency. So X into 2. Now sum of both of these is the total work that gets completed. What is the total units of work? 36. So this is equal to 36. What you get is 10 plus 2x is equals to 36, or 2x is equals to 26, 36 minus 10, or x is equals to 13 days. That's it. So 13 days becomes your answer. Understood? This way you have to draw it. Above will be the time, below will be the efficiency. Then you multiply them and add them like this. Equate them to the total units of work. That's it. Now, let's do another question. Yeah, this. What it says, Ram and Sham work on a job together for 4 days and complete 60% of it. This was in CSAT 2016. Ram takes leave, then Sham works for 8 more days to complete the job. How long would they take to complete the entire job alone? Now see, Ram and Sham work on a job together for how many days? Together they work for 4 days. Time I write above, efficiency I write below. Okay, so they work together for 4 days. Who? Ram and Sham. I don't know the efficiency of any of them, so I am writing R plus S. Okay, let their efficiencies be R and S. Now what is given? And complete 60% of it. And complete, so this is time, this is efficiency. Now this is 60% completed. That means 4 into R plus S is equals to 0.6 W, or 60% of work that gets done. Understood? Now next part, Ram takes leave then and Sham works for 8 more days. So 8 works. Who is working? Only Sham. Correct? Only Sham is working for those next 8 days and he completes the job. Now 60% काम तो already हो गया था. 0.6 W was already done. 60% of work is 60 by 100, that is 0.6 W was already done. Now next is 8S is actually what? 8 into S is actually the remaining work, that is 0.4 W, because W is total work that we have assumed. So W is, let's say, total work. Then 60% of W is 0.6 W, 40% is the remaining 0.4 W. That's it. Now what you can do? You can multiply this by 2. So what you get? You get 8R plus 8S is equals to 1.2 W, because this will also get multiplied by 2. Then this is what? This is 8S is equals to 0.4 W. Correct? Now what you can do? You can simply replace it or subtract it, whatever. So 8S is 0.4 W. Just put it here. So what you get? You get 8R plus. In place of 8S, I am writing 0.4 W plus 0.4 W is equals to 1.2 W. Now 8R becomes equal to what? 1.2 minus 0.4, that is 0.8 W. Now I multiply both sides by 10 to remove this decimal. So this becomes 80R is equals to 8W. How many times this will go? Cross 1 time, 10 time. So what you got? You got W is equals to 10 into R. Have you seen this before? Have you seen some expression like this before? Yes, this is nothing but work is equals to time into efficiency, because R was the efficiency. So this part is done. So what you are getting is actually time taken by R to do it completely alone. Correct? And that is what is asked. How long would R take to complete the entire job? So this will be how many days? 10 days. By simple comparison, you can get to it. Understood? Okay. Now, next question. Yeah. A can do a piece of work in 40 days. He works at it for 8 days. Then B finish the work in 16 days. How long will they take to complete the work if they do it together? Okay. Okay. Now, see. Again, I draw a timeline. Okay. Now see this. A can do a piece of work in 40 days. Now, see, it is not given in how much time we will complete the job. So what I can still assume is work done is equals to what? Time into efficiency. This is true, correct? Now let's do work. Total work in this case will be efficiency of A is, I assume it to be A. Now how many days A takes to complete this? He takes 40 days. So this is 40A. Correct? That means total work is equals to 40A units. So this is the work that we assume. That is total work is 40A. Understood? You can also do it using making efficiency of A is equals to 1, but all that is not needed. This is much more logical. So 40A becomes the total work. Now, let's see it further. A can do a piece of work in 40 days. Okay. Then he works at it for 8 days. So 8 days, who is working? A. Okay. Then we finish the work in 16 days. So in next 16 days, we finishes this. Then we finish the work in 16 days. Correct? Now, how long will they take to complete the work together? Now, what we can write here is, this was actually time, this is actually efficiency. Simply multiply them. What you will get? 8A plus 16B is equals to total units of work kitni hai? What is the total units of work? 48. So this is equal to total work units, that is 48. Now it is simple. So this becomes 16B is equals to 40A minus 8A is equals to 32A, or B is equals to 2A. Correct? B is equals to 2A. Now, once you get B is equals to 2A, then it becomes fairly easy. Now, what combination is given to you? So, 40A is the total work upon effective efficiency gives you the time. Correct? Total work, this we have seen before in first, second lectures. Total work upon effective efficiency. Now, total work is what? Total work is same 40A divided by effective efficiency is what? Effective efficiency is actually A plus B. Now, A is A, that's fine. B can be written as 2A. So, effective efficiency becomes 3A. So, 40A divided by 3A. Now, of course, A and A will cancel out. 40 by 3 will remain. That is 13.33 days. This is the amount of time that will be taken if they do it together. Understood? Okay, so this is how you do questions. When one person comes, one person leaves, simply draw the timeline, write time above, efficiency below, multiply them, and then add all of this, gives you the total units of work. If total units of work can be calculated, if A and B alone everything is given, calculate total units of work. If that is not given, only one person is given, use something like this in variables. Also, another way is you can take efficiency of A to be 1. That way also you can do this. So if that is 1, then you get 8 plus, now here you will get 16B. Now if efficiency of A is 1, then total units of work is what? Total units of work is 40 units. So what you get? 60B is equals to 40 minus 8, that is 32, or B is equals to 2. So A is equals to 1, B is equals to 2, total units of work is 40. So this becomes 40 if they are working together. So A plus B, 1 plus 2, same answer. Okay, it depends on you. Okay, you can take efficiency of A to be 1 and then calculate B accordingly. Understood? Okay, that's it for this lecture.